today we are doing operations with functions. And the first part of today is adding, subtracting, multiplying, and dividing functions. That's actually going to feel pretty familiar because we did something similar with polynomials. And then we're going to learn how to write and evaluate composite functions. And those can get kind of complicated, so we'll do lots of practice on those. Okay? So the first example are the operations. So you'll be given different equations. A lot of times the equations are in the directions. So I like to highlight what my equations are, or to box them in and circle them. And then for part A, the way that you say that is f plus g of x. Okay, f plus g of x. And you are just going to be adding the two functions together. Okay, so let's take a look. So you have f of x and g of x. We are going to add f of x and g of x together. So this is combining your like terms. So f of x is 4x squared plus 3x minus 1. And then if you want to line these up horizontally, you can. You can also line them up vertically if you want to add straight down. But if you do it horizontally, then you'll probably underline like terms. So this is the only 4x squared, nothing to combine it with. 3x plus 6x is going to be what? Yeah, 9x. And then I have negative 1 plus 2. What's that going to be? Plus 1. All right, and then that's your final answer. So that should feel really similar to what we did in chapter 3 with polynomials. Okay, what do we have to be careful of when we're subtracting? What do we have to be careful of? You're subtracting. Yep, you have to distribute the negative to everything behind it. So now we have 4x squared plus 3x minus 1, but minus, and so I'll put that in parentheses, or when I write it down, if I'm doing this on my homework, I would apply it as I'm writing it. Okay, so the distributive property means this is going to become negative 6x and negative 2. So now I can underline my like terms. So again, nothing to combine with the x squared. 3x minus 6x is going to be what? Negative 3x, good. And then you have negative 1 and minus 2, which is going to be what? Negative 3. Okay, this is another section where we're not going to be using a calculator. I think there's one calculation on here that's a higher exponent where I'll let you use it. Okay, but your quiz on Friday is going to be no calculator, so make sure when you're practicing that you practice without it. Just get some of those mental math skills working again. All right, and then for example 2, we have multiplication and division. We're actually going to do the multiplying ones first, so we'll do A and C, and then we'll go to B and D because they have a special rule. All right, so for A, you have F, and then really, I don't think you'll see a space in there. Sometimes you might see a dot like that means multiplication. Okay, so we're going to multiply f of x times g of x. That's what it means. So let's set this up. This is 6x squared minus x minus 12. So put that in parentheses, and then your g of x is 2x minus 3. So again, we've done problems exactly like that in chapter 3. It's just the notation here is a little bit different. So you can distribute, you can multiply everything by 6x squared, then negative x, then negative 12. You can, I'm going to do mine the opposite way. I'm going to multiply everything by 2x first, and then
I showed you this trick when we did this before. If I'm multiplying everything here by 2x, sometimes I'll write this out just to help prevent me from making small mistakes so that my eyes are going just back and forth. Then I can say 2 and 6 is 12. That would be x cubed. 2 and negative 1 is negative 2, x squared. 2 and negative 12 is negative 24, and then keep the x. Okay, so I like that. You do what works best for you. And then do the same thing with negative 3. So I'm going to write this out. Like I said, for me, I feel like that gets rid of small mistakes. When visually I can just go back and forth. So negative 3 times 6 is negative 18x squared. So I like to line mine up here. It's okay if it goes into B. We're going to kind of block this one off. And then negative 3 times negative x would be positive 3x. And then negative 3 times negative 12 would be positive 36. So then I can just add straight down. 12x cubed. Negative 2 minus 18 is negative 20. Negative 24 plus 3 is negative 21. Okay, and then this would be your final answer. Okay, so we're going to block that part off. We're going to come back to B. I'm going to have you guys do C. Okay, so it's just g of x times h of x. Okay, so just keep that there. Okay, so your g of x is 2x minus 3. Your h of x is x minus 4. So all you had to do was FOIL, right? Remember how to FOIL? Yeah? Okay, good. So 2x squared, and then inside you have negative 3x. Outside you have negative 8x. So what do you get when you combine those? Yep. And those are your like terms. Remember, a lot of times the two inside ones are like terms. Okay, so that is part C. Okay, we're actually gonna do part D first. I've decided. So when you have division, okay, there's something special about division that you have to make sure you identify part of the domain. So when we set this up, the division is h of x over g of x. But what can't happen is if you have a fraction, what's the one thing you have to look out for? What can't you have in a fraction? No, you can have those. What's that? Zero where? Yeah, you can't have 0 in the denominator. Because can you divide something by 0? Right? If you're trying to share cookies with people, nobody wants one. You're stuck with all the cookies, right? You have at least that one pile. So, stuck with cookies, that's an oxymoron, right? So you have to make sure that you identify that g of x cannot be 0. Okay, so this is something that we're going to add on after we do our simplifying. So in this case, your h of x is x minus 4. The g of x is 2x minus 3. And sometimes you can simplify, other times you can't. There's nothing that you can factor here. So you are going to leave it like this, and then you're just going to say where, and you have to find what x can't be. Okay, so it will be this, where x cannot be, and then we're going to find that answer. So if this can't be 0, if the denominator can't be 0, then you set 2x minus 3 equal to 0 and solve. Okay, so we're just going to add 3 to both sides, divide by 2, so x cannot be 3 over 2. And then this would be your full answer. So again, this is something special with division because you have a fraction, okay, and it's where x cannot be 3 over 2, okay? All right, now we're going to go to B, part B. So part B, you have division. You have f of x over g of x. But this one's going to be a little more intensive because your f of x is a trinomial. So you have 6x squared minus x minus 12. So what you want to try to do with the trinomial is what? Factor it. Now, when you're trying to factor, okay, and you have 6x squared, you don't have to write this part down. We're going to figure this part out together. So if you had the 6x squared minus x minus 12 and you were trying to factor, okay, you have more than one option for how to break this up. What's one thing that you could start with here? Okay, so 6x and 1x, or, you guys said it, 3x and 2x, right? So it's one of these. When you are factoring and you have a denominator, what we're really trying to see is if it cancels out. Something will divide out. Okay, so see how the bottom has 2x minus 3 in it? We're going to use that to kind of help us as a shortcut for when we're trying to factor. Because let's see if 2x minus 3 would actually work. So if I had 2x minus 3 here, what would I have to put next to it? 4. Okay, so 4, positive 4. 4 times negative 3 is negative 12. Yep. 3x times 2x is 6x squared. Yep. And then we'll check the inside. 4 times 2x is 8x. 3 times negative 3 is negative 9x. So when you combine your like terms, you have negative x. Yep, so that checks out. Okay, so now we're going to write it in factored form. So we figured out this was 3x plus 4 times 2x minus 3 divided by 2x minus 3. Okay, and you can write those all as factors. So remember that multiplying and dividing are inverse operations. So what's happening here is you can think of this, well, it is division. 2x minus 3 divided by itself is going to be what? What's anything divided by itself? 1. So those are going to cancel. Okay, when you do that on a test or quiz, try to do it like that where I can read what's underneath it. Okay, and then your final answer, this is your simplified answer, the 3x plus 4, but again, anytime you have division, you have to say where x cannot be, and you're always going to have something that x cannot be. Okay, so you always take your g of x, okay, because the denominator cannot equal 0, so I'm just going to put that over here. So in this case, your denominator is g of x. So g of x cannot be 0, which it's 2x minus 3 again. Didn't we just solve this? Wasn't this the same? G of x was on the bottom. Okay, so what can x not be? Three over 2. Same thing, right? Same exact equation. So x cannot be 3 over 2. Because what that means is you wouldn't even be able to cancel it out. You have 0 over 0, which is an indeterminate situation in math. Yeah.
Why wouldn't we do it with the 3x plus 4? Like, instead of canceling out 0.
Because that's in the numerator, and the numerator can be 0. So the only problem is if you try to divide by nothing, by 0. But you could share 0 with everybody. Everybody could have none, and that would be fine. That would all be easy. Okay, all right, now we're going to evaluate. These are, this is a 2-step process. Okay, the first one I'm going to go over slowly, and then as we practice it, you're going to get really good at it. So you are given 2 equations, f of x and g of x, and then what you have to do is find each value. Okay, so this is a composition. See how you have f of g of 4? Okay, what we're going to do is we're going to break this down into 2 separate steps. So the first thing we're going to do, we're going to start with the inside, and we're going to find g of 4. So g of 4 just means you're plugging 4 in for x into g of x. So we did that the other day with piecewise functions, right? We plug it in for x, same thing. So 7 minus 4 is going to be what? 3. Okay, now that's what we're going to take with us to step 2. And what we're going to do in step 2 is we're doing substitution, right? We're going to substitute, and we're going to find f of 3. Because really what we're doing here is we're taking g of 4. If we know g of 4 equals 3, we're just going to plug 3 in here. That's why it becomes f of 3. Do you guys have a question about that? So whatever you find in step 1, okay, you're substituting that in. So now we can just find f of 3. So f of x is 2 to the x. So f of 3 is 2 to the 3rd, which is going to be what? 8. So then your final answer, f of g of 4 is equal to 8. So you're going to start from the inside, and then you're going to work your way out. All right? So that means for step 1, what are we going to find first for this one? F of 4. Okay, so you guys find f of 4. I'm going to plug it back in for the second one. Once you guys get it, you can go ahead and do C. Okay, Ashley, what'd you get for f of 4?
2, 4.
Yeah. Yeah, 2 to the 4th, which is 16. Great. Okay, and then, Sam, what do you do with the 16?
You put g and then the parentheses 16.
Yeah.
And then 7 minus 16.
Great. Okay, so now you're using that into g. G of 16 will be 7 minus 16, and that will give you negative 9. Great. Okay, so we would say g of f of 4 equals negative 9. Awesome. All right, now C is the one where I wouldn't give you that no calculator test because the number's kind of high. But let's see if we can do C and D. D you should be able to do without a calculator. Okay. Alright, so for C, when you do g of negative 3, what did you guys get? Rashawn, what'd you get for g of 3? Or g of negative 3? That would be the second one. Boy, what'd you get for g of negative 3? Yes. Okay, because you have minus and negative, so that's going to become plus, right? So 10. And then, yeah, and then in your second step, you did f of 10, which is 2 to the 10th. Okay? If you did have to do that one mentally, think about something that you know. Like, do you know what 2 to the 5th is? 32. So you could just do 32 times 32 if you had to do that without your calculator. Okay, but you can do that with it. What did you guys get? 1,024. Yeah? So this is f of g of negative 3. All right, great. All right, so for D, the first one, f of negative 3, when you plug that in, it's 2 to the negative 3rd. Okay, Getcha, do you remember what that's going to be? 2 to the negative 3rd? What's 2 to the 3rd? 8. So if it's a negative, you guys remember? Yeah, 1/8. Good. Yeah, it's a fraction. 1 over 8. Great. All right, and then now I'm going to do g of 1/8, which is going to be 7 minus 1/8. Cooper, do you want to tell me how you thought about this one? Because I saw you had the mixed number for that one. Oh, Cooper?
I did 7 minus 1/8.
Yeah. I always think of like the 1/8. What will make that a whole number? 8 over 8. So like he said, he got the 7/8. I do that part first. Because 7/8 and 1/8 is 1, right? And then 7 minus 1 is 6. So you can leave it like that. Okay? Or if you wanted to write it as a mixed number, 8 times 6 is 48. 48 plus 7 is 55. Okay, so either one of those are fine. Okay, but it should be one of those because you want to use a calculator for it. All right. Now we're going to do composite functions. So composite functions are similar to what we just did here. The only difference is for these, we were using numerical values and plugging them in. Now what we're going to do is we're going to plug an equation into an equation. So we've been plugging numbers into equations. Now we're going to plug an equation into an equation. Okay? So the first thing we have to do is talk about the format. So, and domain is going to be a big part of this. Composite functions have 3 different forms. Here's the first one with lots of parentheses. Here's the second one, which also has a lot of parentheses. And that is an open circle there. So it does not mean times. Okay? Times would be a closed circle. Okay? This is an open circle, which is the composition. Now, because these all mean the same thing, we pronounce them all the same way. So what this means is, or the way that you say this is f of g of x. So this is f of g of x, this is f of g of x, this is f of g of x. Okay, and they are compositions. Okay, now what this means is we're going to do some substitution. Okay, so this means we substitute g of x. So the inside, just like we did before, we substitute g of x, so write this down with me, into f of x for x. So we're going to substitute a whole equation in for x, not just a number anymore. We're going to put a whole equation in there. Okay? And then you're also going to be asked about the domain of this new function once you simplify it. So with the domain, remember the domain is the set of what? All the x values, right? All the possible x values. Now, it's too difficult because there's so many numbers to think of everything you can plug in. So instead, it's simpler to think of the restrictions. So what values can I not plug in for x? And there are a couple of things that we can narrow down to look out for. We already talked about one of them on the front page, right? The fractions. Because if you have a fraction, what's the problem there? Yeah, where? In the denominator. So the first thing you have to watch out for are fractions. Okay, because the denominator cannot be 0. All right, what are some other functions that we've looked at this year that have restrictions on the domain? We did one last chapter, we did one early on. What else? What do you think? What are some functions that don't have a domain of all real numbers? Yes, the square root, right? Because the square root can't have what? Yes. Okay. So I'm gonna call them radicals. So radicals, that includes the square root. Okay, you can't take the square root of negatives. Can you take the square root of 0? Let's try it. You don't seem sure. Am I going to get an error? Am I going to get an answer? Remember, a square root just means, can you multiply something by itself to get that number? Or multiply something by itself to get 0? Yep. So it includes 0. So it can be 0. That's fine. The way that we'd write this using mathematical symbols is we would say that the value, whatever's underneath the radical, which is called the radicand, has to be greater than or equal to 0. Now this only matters if it is an even root. So we talked a little bit about some other roots because we talked about the sum and the difference of cubes. So think about why that is. I can take the cube root of -8, right? I won't get an error. What will I get? What multiplied by itself 3 times is going to be -8? -2, okay? So that's fine. But if I were to try to take the square root of -8, then I'd have non-real answer. Right? That's the problem. Okay. So I would get an error there. That's because if you're multiplying, if you have an odd number of things you're multiplying, what happens when you multiply a negative by a negative? Positive. But then see how I'd have to multiply it by -2? It ends up negative. Is that ever going to happen if I have an even number? No, because if I have an even number of negatives, I have a negative times a negative, which is positive, and then I have another negative times a negative, which is positive. So then it ends up being positive. Okay, so we've worked mainly with square roots, but if a 4th root pops up, same thing happens. We're going to talk more about roots in Chapter 5, which will be here next week. All right, and then the last thing was in Chapter 4. You had it on your exam, right? What has a domain of not all real numbers? The what? No, not necessarily. Yeah, the log. Remember, you can't take the log of what? 0 or a negative. Okay, so with logs, can't take log of 0 or a negative. So how would that change from this one? Because this one included 0. What kind of symbol would I need for this one? No? So this one was greater than or equal to 0? It's just greater than. Okay, so we would just have to set whatever the log is of greater than 0. Okay, the good news is you don't really have to deal with logs much in this. Alright. So, for this set, we are going to be given a bunch of equations, and then we have to find the composite function. When you are finding the composite function, this should be simplified. Okay, so we're going to make sure that we simplify. And then we also have to state the domain. Okay, so if we're stating the domain, that's where this box is going to come in. The domain is also going to be written in set builder notation. Do we remember what that is? Remember set builder notation? What does it have? No. It has those fancy brackets. Remember the fancy bracket, x such that x is, and then really we'll just put dot 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 because we don't know what it is. It's going to change. All values of x such that, and then something will happen to that. Alright, now I'm going to give you some strategies for doing this, and then as you practice it, you'll be able to kind of just plug things in all at once. But since we're just starting, okay, I recommend that you look at the outside. So this means f of g of x. So we're going to plug g of x into f of x for x. So a good thing to do is to look at f of x. Okay, so f of x equals x squared minus 1. There's only one x term in this one. So what I'm going to do is I'm just, instead of the x, I'm going to put parentheses because that's where I'm plugging things in. So this is x squared minus 1. Okay, so x squared minus 1. Now I have to replace this with your g of x. So g of x gets substituted in for x. Okay, and g of x in this case is x over 1 minus x. So I'm going to plug that in. X over 1 minus x. Okay, and then we simplify. So if we have something that's to a power of 2, we are going to simplify that. You can either think of it as writing this out twice and multiplying, or when you have a fraction, you just square the top and you square the bottom. So it looks like this. You have x squared on top. On the bottom, you have 1 minus x squared, and then you can keep the minus 1 on the end. Just remember that when you have this, you do have to FOIL. So you'll have 1 minus x times 1 minus x. That's what it means when you square it. Okay, and then go ahead and FOIL that.
make sure you keep the 1 on the outside, and then we'll simplify it together. So then when you FOIL, you should have got 1 minus 2x plus x squared minus 1. And then generally when you write this out, you'll put the bottom in standard form. So your final answer will be x squared over x squared minus 2x plus 1, because the 1 is positive. This one's negative, minus 1. All right, and then we just have to do the domain. So for the domain, just again, go through this list. Is there a fraction? Is there a radical? Is there a log? So which one do we have here? We have a what? Fraction. So with the fraction, all you have to do is we know that the denominator cannot be 0. Okay, so we're just going to set x squared minus 2x plus 1 equal to 0. And solve for x. Okay, and this is factorable. In fact, if you wanted, you could just factor it like this, or this also factors into x minus 1 and x minus 1. Right? X times x is x squared. This would be minus 2x plus 1. Okay, and then set each one equal to 0 and solve. Now remember, whatever you get, in this case, you would get x equals 1 for both of them, but you have to make sure when you're writing your domain, you cross it out. So the domain is x can be any number except for 1. So all real numbers x such that x cannot be equal to 1. So that's how you'd write your final answer. Part B. So again, we start with the outside. So we have g of f of x. So it's the reverse of what we just did. So again, I'm going to start with the g of x. So when I look at g of x, I see x over 1 minus x. Instead of x, what have I suggested that you do? What did I suggest you put instead of x? Parentheses. So this is going to be parentheses on top. X over 1 minus x. Now you can do the substitution. So we're going to plug f of x in. If there's more than one x, like there is here, you're just going to plug it in into both of those places. Okay, now there's nothing to simplify on the top, so you can leave it as x squared minus 1. On the bottom, though, you do have to make sure you distribute that negative. Okay, so this becomes 1 minus x squared plus 1. You can leave your final answer as 2 minus x squared. Sometimes people do that so you don't start with a negative. Okay, or you can write it as x squared minus 1 over negative x squared plus 2. Okay, so either one of those are fine. You don't have to go any further than that. You don't have to factor the top. You can leave it just like that. Okay, so again, we just ask ourselves, is there a fraction? If there is, then you take the denominator, okay, and since the denominator can't equal 0, you just set it equal to 0 and solve. So if you have 2 minus x squared equals 0, I would solve by adding this to both sides.
And then if I have x squared, how do I undo the power of 2? Take the square root. When I take the square root, what do I have to remember to put with my answer? Yeah, the plus or minus the root 2. Okay, so your domain is going to be all values of x such that x cannot be plus or minus root 2. Okay, and then I want you to try part C. So I want to make sure that you can do the substitution. Plug that part in. I recommend looking at what's on the outside, starting there, and then using your parentheses. So use the outside function. And you are going to have to simplify using some FOIL. Okay, let's check to make sure you guys got the right substitution. So f of x, you have x squared minus 1. So when you plug in your h of x, make sure that when you see the squared, if it's a binomial, we got to write that out twice in FOIL. Okay, so when you FOIL, 3 times 3 is 9, so this is 9x squared. These are the same values on the inside and the outside. So negative 12x minus 12x is negative 24x. Negative times a negative is a positive, and then you're just going to have to calculate that minus 1. So this should be your final answer for the simplifying. Now for the domain, we go down that list. Do I have a fraction? That's one of the easier questions I'm going to ask you today. Is this a fraction? No. Okay, and I don't have a fraction anywhere in it, so that's great. Is there a radical? No. Is there a log? No. So that means your domain is what? All real numbers. Do you guys remember how to write that in set builder notation? Okay. So it's all real numbers, x, such that x is an element of the real number set. So this is like a special E. It means element and then the real numbers. Okay, so again, the reason for the domain, there's no fraction, no radical, no log. So once you've done that checklist, that's how you would say all real numbers in set builder notation. All right, D, you're going to have to remember how to multiply whole numbers and fractions. So you have h of x, so we haven't used that one yet. Your h of x is 3x minus 4. Okay, so then you are going to, so you're going to use your 3x minus 4. Welcome, you guys can jump in. And then I'll have you rewatch things, so just let it absorb for a little bit. Okay, so your h of x is 3x minus 4, and then instead of x, we're going to plug in g of x. So we're going to plug in x over 1 minus x. Okay, once you got this set up, when you're thinking of simplifying, we have to multiply these two together. It's a whole number and a fraction. You could put the 1 underneath to remind you that the whole number gets multiplied by what part? Yeah, it gets multiplied by the numerator. So this is 3x over 1 minus x, and then you can just keep the minus 4 on the end. This is going to be your final answer. Okay, and then for the domain, we have a fraction. So we know the denominator can't be 0, which means we set the denominator 1 minus x equal to 0. I would add x to both sides. So I know that x cannot be 1. Okay, because if I plugged in 1, that would make it 0. We can't divide by 0. So x such that x cannot be 1. Okay, and then I want you to try the setup for E. Really, I think you can do the whole thing for E. E and F for sure. Okay, so we try E and F for me.